Hi, everybody. My name is Stephen Ajayi. I'm really excited to be here with you today. I'm the technical lead for the dApp audit team at Hacken and also the AI audit team at Hacken. Here I get to spend most of my days diving into security auditing and generally just breaking things in a good way so that we can help them keep secure. Outside of work, I'm a huge fan of security research. I live for that haha moment when you find critical vulnerability. I've also written a couple of short books, and when I'm not poking around looking for vulnerability, I'm usually writing fictional content. So about hacking, if you've not heard about us, we are a cybersecurity firm that works with majorly Web3 and also Web2 companies. We do smart contract audits, dApp audits, penetration testing, layer one protocol review, AI security assessment, you name it. We also help with compliance things like ISO 27001, VARA compliance, DORA, CCSSA. Yes, the full alphabet soup of security auditing and compliance. Plus, we also run a bug bounty platform called Hacken Proof. We have a smart contract monitoring system called Extractor, and we've got our own token high. Basically, we live and breathe security. And if a company does not even know where to start in terms of security, that's also cool. We offer some sort of custom consultant to help you figure out security together. So before we jump into the details today, we have two books specifically tailored towards AI security. The first one is an AI red team book for hackers, and the second one is tailored towards defensive programming for AI builders. So you can scan the QR code and grab a copy. But enough about that. Let's talk about why we are here today. AI. AI is officially everywhere, whether you're coding, designing, managing projects, or even writing emails. AI has become an integral part of our organization, right? It has crept into all our workflows. I honestly can't count how many times I've used AI this week. If I asked us to do a quick show of hands right now for how many of us have used AI in the past few days, even today, I bet we're going to see like a lot of hands, right? If you're not raising your hand up, definitely your neighbor is. So, what is the security in AI about? That's what we're going to be talking about today. And by the end of this webinar, you won't just understand the theory because we have like a lab that we're going to walk through. We're going to learn about common vulnerabilities and have like a clear defense playbook in hand. Now, about the agenda of today, we're going to talk a little bit about the different type of AI system, um, their core components and anatomy, why organizations are adopting and implementing agentic AI. We're also going to go through some example in our lab, right, and some recommendation. Then we're going to wrap up with some question. I hope you're excited to start, because I am. All right. So anatomy of LLM system. You can't protect what you don't understand, and you shouldn't trust what you haven't verified. So LLM and agent-based system are very powerful, no doubt about that. But with great power comes great responsibility, right? To stay ahead, we need to understand what we are dealing with. So we're going to break this down into different categories and see how each one of them open up different attack surface. So the first one we're going to be looking at today is the rule-based bot. These are your classic if this, then that setup. They follow a predefined script. Think of those frustrating customer chatbot that only understand 5 specific things. What's good about them is they are very predictable and very easy to secure. What's not so cool about them is they are very rigid. The moment you start asking unexpected things, they basically fall apart, right? Because they don't have it in their database or in their coding. Then we have the generative bot, just like your GPT-4, Gemini, your Cursor. They work in real time and can handle open-ended prompts. Now, what's good about them is they're super flexible, right? They're great for brainstorming, for support, even coding help. So what's risky about them is they can hallucinate a lot, wrong answer, they give wrong answer all the time, or even worse, if they're not properly secured, they can be a tool for hackers. Then there is the open source models like the Llama, your Falcon, that give you full visibility and control. You can tweak them, you can audit them, you can do whatever you like with them. What's great about them is you have full transparency. Yeah, you can see everything under the road. So what's risky about them is because you're your own infrastructure, you're also your own security, and you need to implement your own guardrail in them. So if something goes wrong, there is no vendor to be blamed, just your architecture and your choices. Then there is the proprietary model like the GPT-4, the Gemini. They come built in with guardrails already from the company. What's good about them is they are very easy to use. There are different guardrails in place. What's not so cool about them is because you're trusting someone else's judgment. Like, and let's be real, these models still make us stuff. They hallucinate a lot, right? Just a few days ago, I saw a post about some professor ranting on LinkedIn about how his students are submitting AI generated work with zero fact checking. The bottom line is you can't trust AI blindly. You always need to verify whatever AI is giving you, especially when it matters. Then we have the generative what, just like your GPT-4, your Claude. These are like the Swiss Army knives, right? They are good at a lot of things: writing, coding, chatting, researching, but they are used everywhere, and attacker focus on them, so they're high value targets. There's also the domain specific model like the legal AI, the medical AI, the neutron LLM, or even security focused model. So they are trained for a specific niche. And the good stuff about them is they're very accurate in their areas. But you also need to watch out for poisoning in the data, in the training data. Let's say someone is able to sneak in malicious content into their legal data sets. Your trusted AI assistant is going to start giving wrong answers without you even knowing. And that is why it's always important to validate your training set and always clean your input. Now, there is the offline models for those that want to run LLM in a more secure and more privacy-oriented way. You can run locally your LM Studio plus DeepSeek or other open source model and keep everything in-house. So what's good about them is your data is going to stay private on your machine, and the risk is you always need to patch them, right? Because if you don't patch, your model can become a vulnerable time bomb. Then there's also the cloud-based model, just like your Claude, your GPT, your Gemini, your Cursor. They are super convenient and very easy to scale, right? But every prompt you send travel across someone else's server, which can be a target like an opening for vulnerability. A quick example of this is back in that's 2 months ago, that's March 2025, there was a plugin flaw in ChatGPT that got exploited using an old SSRF attack that is targeted towards US government system. And that's just a reminder for us that it's not just your security you need to be worried about. You also need to worry about the third-party tools and library you're also using. Next, we have the text-only model, just like your GPT 3.5 and the earlier version of Claude. They only understand text and that's it, right? They stick to language and they're pretty straightforward. Then there's the multimodal model that understand a lot of things. They can handle image, text, even audios and videos. I mean, it sounds very good for features, but it's also a wider attack surface. Just last month, there was a CVE, I think 2025 43714, if I'm correct. That's a vulnerability in ChatGPT SVG rendering engine that could lead to XSS injection. I mean, it's wild, but it happened, right? So again, even cool new features can become hidden vulnerabilities. So there's also the interactive bots, which are simple. They wait for you before they do anything. You type a prompt, they give you a response, right? Think of your standard chat assistant. Then there is the autonomous agent, just like your AutoGPT, your Baby AGI, or custom assistants. They take things a little bit further because they can run task chain, they can browse, they can fetch data, they can execute action with minimal supervision, right? And that's very powerful, but it's also scary in terms of security because a single prompt injection can quietly turn one of these sleeper agents And what could basically happen? Imagine a prompt that is going to allow your agent to navigate through your system, doing exactly what the attacker wants, all because of a manipulated prompt. That could be very dangerous. So the bottom line for this is, yeah, with every extra feature, for example, whether it's autonomy, multimodal input, model complexity, it adds more way for things to go wrong. So as you're building as a developer and integrating LLM as an organization, you need to map out exactly the kind of model you're dealing with and understand its security need. Next, so let's take a quick peek into the black box, because behind every smart thing your AI does on screen, there are a few critical building blocks at work, right? So today we're going to break them down into three pillars, and these are the core components that makes your AI assistant so smart. But they're also a potential entry point for attackers if they are not properly secure. So the first one is the retrieval. So this is like the AI memory extender. It helps you fetch knowledge from outside sources, documentation, API, databases on demand. So it powers things like the retrieval augment generation. So the security risk about this is if your data store is not clean, attacker can inject malicious content into your sources, like slipping a booby trap PDF into your vector databases. And if your AI assistant is not sanitizing content before using it, it could end up executing unauthorized command, which is going to leak data or provide totally false answer. Just imagine somebody embedding an ED instruction that only activates on a certain word, right? It's going to like quietly start exfiltrating files. Then there is the embedding store, which is your vector database. This is where your system store the meaning of documents, right? So it store it in vectorized chunks of your company's knowledge, specific knowledge, which is always ready to be pulled whenever it's needed. So the security risk about this one is if an attacker can poison this with bad data, you're not just getting wrong answer, you're getting answer that is designed to mislead, to open backdoor, to do different or trigger insecure logic, right? So the AI is going to think that it's actually helping you, but it's really following a rigged trail. So this is what we call the vector store poisoning, and yes, it's already happening out there. Then the third one is the orchestration. This is the one that has to do with your functions, your tool calls. This is where things get very powerful and risky at the same time, because orchestration is how your AI knows what to do next. It might decide to call an API, run a CI/CD command, or even interact with external tool. So the security risk about this is if your security is not solid, right? Attacker can hijack it with clever prompts. This might trick the AI into running sensitive function or even escalating privilege or taking over the whole system, whole system. And this is one of the most complex attack surface in modern AI system, because now we are not just talking about bad answers and hallucination, we are also talking about dangerous action. So the takeaway about the component is these three layers, they work together hand in hand to make your AI system very smart. But at each step, there's a handoff, and every handoff creates a new opportunity for attackers to sneak in. So the smarter your AI gets, the more careful you need to be about what is allowed to do in terms of reading, remembering, and actually carrying out action. So up next, so why are organizations actually betting big on agentic AI? Well, before we dive deep into the hack and the attack part, it's better we zoom out for a second and understand why organizations are actually throwing huge budget at agentic AI. Why is everybody rushing to adopt it? Because even with the risk that is still unfolding, a lot of organizations are implementing this into their workflow. It's simple because it works. Because if these two were not genuinely transforming how teams operate, nobody is going to lose any sleep over it, right? But they are. So we're going to break down why AI is actually exploding across different industries. The first thing is productivity, because you're doing more with less time. So AI is actually very powerful when it comes to automating boring stuff. AI can help you draft your emails, summarize meeting, write boilerplate code, It can even help you build up with few crafted prompts. Some folks call it vibe coding. Yes, what you just need to do is you just need to describe what you want, and it's going to start coding. And there was a study back in 2024, I think that was done by IDC, that found that LLM assistant has helped different organizations cut down documentation time by 30%, and that is actually very huge. And there's also the faster problem solving, because you don't need to dig through several folders or outdated Confluence pages anymore. You can actually integrate AI-powered search that is going to allow your team get straight answers from internal documentation and knowledge instantly. Then there's also the knowledge acceleration. Developer can ask AI to debug logs, suggest fixes, or walk them through errors, right? In fact, there was this research done by IBM. They used GPT-4 on a wide range of one-day vulnerabilities, and it successfully exploited, I think, 87% of all their vulnerability in a sandbox. That's how powerful these models can be. And yeah, it's both good and bad at the same time, right? If it's not implemented properly. Then there's the knowledge management. AI can be like a single brain for your company. Instead of chasing information across Slack, emails, Google Drive, AI can help you unify everything, because it can actually serve as a centralized system, searchable brain for your organization. Then there's also the reduced knowledge silo, whether you're in HR, DevOps, whatever sector you are in an organization. If you can prompt it right, you can tap into the knowledge that is being used in another team, which is also good. Then there's the faster onboarding for new employee, because you don't need to keep asking around where to get documentation, how things are done. You can basically have an AI assistant that is going to help them navigate the whole company knowledge base from day one. Then there's also the cost reduction. AI can help act in terms of self-support system. It can help you handle repetitive questions, reduce support tickets, and freeing up human teams for higher value work. Then there's the reduced context switching. You don't need to bounce between different tools anymore. For example, Jira, Slack, documentation, AI is going to bring all that context into a single interface, and that is a huge time saver. Then there's also the process optimization. AI can help you review your CI/CD pipeline, the Terraform config, your build step, anything you have. It can help you spot inefficiencies in your workflow and even security gaps, right? It can give you secure scope, if you give it secure scope access, actually. Then there is the enhanced decision making. AI can basically help you in terms of analyzing data, right? AI, it doesn't just give you data, right? It also helps you interpret them. It breaks it down into understandable chunks. And it can also be helpful in terms of risk assessment. Whether you're reviewing a contract or a budget proposal, AI can highlight some gaps in your proposal. For example, compliance gap, maybe some potential oversight that you skipped, or even legal risk before you even open the document at all. Then there's also the alternative generation. AI can suggest multiple approach for you to solve a problem, right? So it can give you new strategies and different approaches to solve one say problem. So the bottom line is the adoption of AI is not just because of the hype. It's actually return on investment, right? Organizations are not just adopting AI because it looks good on the press release, right? They're doing it because it actually saves time, it reduces cost, and it also leads to better decision. That's if it's used properly. But here's the catch. Every single benefit, from speed to collaboration to deep insight, come with a risk if you skip security. So the more connected, the more capable and autonomous your AI agent gets, the more critical it is to lock things down. Now, where does security emerge? So let's get to the heart of it. Here, we're going to be looking at how powerful AI systems are, exactly where vulnerabilities actually slip into those cracks. So it's not just about LLM doing AI things, it's about how all these pieces around the LLM can be exploited if you're not thinking security first. So we're not just going to be talking all the good things that AI is doing. We're going to break down the few weak spots that attackers love to target. And one of the weak spots is the system boundary issues, right? Once you let an LLM run command and access sensitive data directly, the clear line between what is safe and what is dangerous actually becomes very blurry. There is a real world example that's April 2025, that's 2 months ago. Researchers showed how a ChatGPT agent with function calling accidentally got SSH access to critical servers. That's a prompt injection into full server takeover, just like that. Then another thing is, if your internal service are not properly segmented, one breach in a single microservice can allow attacker to actually move laterally into your entire infrastructure, and all it takes is one weak link. Then there is the authentication and authorization gap. So some AI application actually check a user permission, but it's only done once at the login stage, and after that, it's actually a free reign. Imagine somebody with read-only access able to trick the AI into writing or deleting sensitive data. So a lot of this AI workflow uses OAuth tokens to connect to other apps, and if these OAuth tokens are not properly scoped and locked down properly, an attacker can actually each ride on those tokens. Then there's the content filtering limitation. LLMs struggle a lot to fully block prompt injection, especially when those instructions are hidden in the middle of document or prompt. OWASP actually listed prompt injection as the number one threat in 2025. And that's for a good reason, because the user can actually hide malicious command in the footnote note of a policy document, and the AI is going to run it, right? If a proper guardrail and context filtering is not properly done in the system. Then there's also the internal threats, because a rogue employee, or for example, let's say a developer that is actually training this AI can slip in trigger phrases into your vector databases. And later, when this phrase is being queried by the system, the AI is just going to think it's doing its job, but it's actually executing malicious command. Then there's the tool invocation vulnerabilities. If your AI is allowed to run shell command or call API or interact with external services, a cleverly crafted prompt can exploit that. So, and we're going to also see an example of this in our live demo, where we use a prompt injection to trigger tool execution in a way that it should never be done. Right? So if your function calling setup lacks proper security control and checks, an attacker might directly hit those endpoints. Then the last one is the data retrieval weaknesses. So this one is actually very sneaky. If your embedding store is compromised, right? If malicious documents can be injected into it, it's a problem, because it's going to give an attacker a way to take over your system. So in February 2025, there was this security audit that revealed DeepSeek R1 vector database has been poisoned. Under the right query, it's going to return hidden backdoor command instead of safe content. So the bottom line is, cool feature does not mean or does not equal to security features. If your development team build features without a security mindset, you're basically handling hackers in menu, and not just the elite hacker, because even anybody, right? They're called vibe hackers now, can just use AI, and with a clever prompt, they can cause real damage. So every shortcut in development become a potential attack path. So before we build smart, we need to start thinking on how we can actually build secure. Now, real world context to really understand the risk. Let's just take a few minutes to understand how organizations are actually using this LLM in the wild, because most deployment is going to fall into a few patterns, and we're going to categorize them into three patterns. So the first pattern is the isolated assistant. This is your most basic setup, right? That's an AI assistant that is used for lightweight tasks like writing, brainstorming, and answering general questions. There's also the retrieval augmented assistant that has to do with pulling in real data from internal document, knowledge bases, external APIs to make the assistant smarter. Then there's the tool using assistant. In this setup, the LLM can run tools, can issue command, call API. It can even trigger action in real system, right? So it's not just reading; it's actually carrying out an action. So, and this setup are actually a real productivity booster, but they're also going to expand your attack surface. For example, command injection can slip in, tool abuse can slip in, logic manipulation is there, and so many more attack surfaces. So there's also the agentic system. This one is full autonomous, right? Just like the Auto GPT and Baby AGI we mentioned earlier, they can plan, they can decide, they act on their own to achieve goals. So they can also chain multiple actions together, and there's minimal human oversight. They are very creative but unpredictable, and it's very risky. Yes, they are good for and amazing for automation, and they can scale, but without security controls and checkpointing, uh, one prompt can actually be used to carry out malicious action because there is no proper checkpointing. It can think for itself. It can carry out unpredictable action to just achieve a goal. So what we're going to be focusing on in our workshop today is we're going to be looking at the pattern 2 and the pattern 3. That's the retriever augment assistant and the tool using assistant. And that is actually part of the real world sweet spot for organizations right now. It's where AI moved from cool experiment to business critical, and where the security stake becomes very real. Now, why LLM security matters is because the stakes are sky high. Let's face it, LLM are not just research toys anymore. They are in our inboxes, they are powering our customer support, showing up in government system, and they are baked right into the tool we use to work every day. So we've crossed that line, and we can't almost do anything without them anymore. So why this actually matter is because every department in every organization is basically leaning on AI to make decisions right now. So, and that means that they are no longer a cool side project. They are part of our main workflow. So AI is now acting like the backbone of a lot of business processes, right? And across every business and every industries. So the upside for this is AI is going to make us very efficient. We have faster ways of doing things, faster recommendation, faster reporting, quick insight from mountains of data. It's actually a productivity booster that we've never seen before, right? But on the flip side, there is data leak. Without strong guardrails, sensitive data or regulated data can actually slip through the crack. There's hallucination. Sometimes AI like to make up stuff. And a use case is that we can actually look at is the Anthropic court case, because they got sued by Universal Music for generating copyright lyrics. Imagine that happening in an enterprise data. Then there's also the adversarial attack. Hackers are not just sitting down still, right? They are probing LLMs and agents for security vulnerability, trying to trick them, coming up with intelligent prompt to exploit them and turn them into access points. Then regulatory pressure is also there. Regulatory is actually storming the building. Governments are watching. There's GDPR, there's the EU AI Act, and there are also sector-specific rules popping up every day. And if you miss a compliance check boys as an organization, you're going to be looking at fines, there's lawsuits, and the kind of PR you want to actually run away from. And the business impact is also brutal. There's the intellectual property theft, there's bad data breach, and you can lose trust, you can lose your customer, and probably a lot of money, or even worse, the reputation damage you're going to get from this is going to take years for you to fix. Now, the quick analogy for us is we need to think back to the early 2000s, where everybody suddenly needs some sort of web application penetration testing, firewall, secure coding best practices, and the likes of it. Well, we are at the same point right now, but with AI security. The only difference is everything is moving faster. An attacker, they've got AI superpowers right now also, right? So if we are building cool features without thinking about security, we are basically handing the attacker a backstage pass into our infrastructure, and we honestly don't want to do that. Now, to ground this conversation into reality, let's look at real-world attack and vulnerability from the past years. And these are not just in research paper or test environment; they're actually live and being exploited right now. So the first one we're going to be looking at is the prompt injection, and this is the most common one. This is when attacker crafts prompt to trick your AI into doing something malicious. And they come in two flavors. There's the direct prompt injection, which is the obvious prompt like ignore this instruction and do X. Then there's the indirect prompt injection, that is when you're hiding malicious instruction inside the document, maybe a data feed or even an API response. Then there is one misconception about prompt injection and jailbreaking. Prompt injection is not equals to jailbreak, right? But jailbreak is just one possible outcome of prompt injection. All jailbreak are prompt injection, but not all prompt injection is going to become a jailbreak, right? So we actually show an indirect prompt injection example with basic setup in our AI Red Team handbook. You can grab a copy from our blog post, from our website, actually in the blog post section, and you're going to see how it works. Then the second vulnerability is the chain of thought poisoning, where attacker can embed malicious logic into the multi-step reasoning of an AI so that the AI can learn to do the wrong thing by the end of the chain, right? A real example of this one is back to February 2025, they will say researchers that poisoned Gemini long-term memory using a document that is hidden with malicious logic, right? Week later, when a certain phrase was seen by and processed by the AI actually triggered a malicious tool call. The actions was delayed quite all right, but at the end, it was actually devastating. Then there's the data poisoning. This happens when an attacker can actually corrupt the training data of the model itself so that the model can learn incorrect pattern. So this basically happened during training so that the poison behavior can stay buried until it's been triggered by a specific trigger word. Same thing as the sleeper agent vulnerabilities, which are like hidden backdoors in model that remain dormant until it's been triggered by a specific phrase or a condition. Then, yes, there are CVE on the rise. There are a lot of CVE in 2025 alone. There's this CVE 25, the one I talked about earlier, the 43714, that's the SVG XSS injection. There's the Spring Boot Open API vulnerability, which has to do with the misconfigured access control that let an unauthenticated user delete other users' chat history. Then there's the SSRF in ChatGPT. Which is actually a year-old SSRF, but is being used to exploit an open source ChatGPT wrapper, which was used against the US government and financial institution. So there's also the AI-powered exploitation. Even hackers with low technical skills right now are very dangerous because they use tools like code interpreter or open source model or even ChatGPT, Gemini, Claude to generate malware, phishing pages, and exploit scripts. So all they need to know is actually the right prompt to use, not to even have any coding skills. Then there's the privacy and side channel attack. AI might accidentally review data it was trained on, or attacker can also come up with clever queries to extract sensitive information from this model indirectly. Then there's the denial of service attack. This is actually to flood the AI with several requests, either crashing it or making them unusable for a period of time, right? Then the next one is the AI misinformation and risk. Misinformation risk, AI love to sound very confident in an incorrect response, right? And when people act on the information without verifying them, is going to cause real damage, especially in high-stake environment like health or finance, right? Then there's the over-reliance and compliance gap. The more we trust in AI to do all the thinking for us, the more risk we take on, right? If it's wrong. So especially when it comes to regulated industries where bad advice can actually lead to non-compliance. Then there's the model cloning And theft, this one, I'm not sure we can ever propagate, curb this one, because it has to just do with how attacker can ask the AI ask the AI a lot of questions to create a similar AI, right? Basically stealing your intellectual property, right? Um, as long as your AI is online and people can subscribe to it, people can come up with different queries and probe your AI and use your response to build their own model. Then there's the supply chain risk. LLM, just like other applications, rely on different mix of third-party tools, models, API, and different plugins. So even if one of those third-party tool is being compromised, your whole system can be at risk. I don't know if anybody can remember the Log4j vulnerability that happened a couple of years ago. The bottom line is your AI system or your application is only as secure as its weakest dependency. So now, what we're going to cover today, everybody can actually navigate to this link because this is why we hosted our DevOps AI assistant. So everybody can just go straight right to it. And I'm also going to share a GitHub page in just a second in the chat. Okay, so that GitHub page is actually the workbook that we're going to be using today. So, all right, so let's jump into the fun stuff. We've actually built in a realistic DevOps assistant, which is an LLM agent wired into real DevOps stack. So, but here's the twist. We actually intentionally laced it with vulnerability. Why? Because the best way to learn about how to secure the system is actually to break them first. So in our lab, we're going to walk you through exactly how attacker can chain multiple exploits together, and then you get to take the wheel and also try it yourself. So the attack path scenario is we have the chain of thought poisoning, where we are going to be seeing how innocently crafted prompt can actually trigger tool usage in the system. There's the tool hijacking vulnerability, vector store poisoning. Then we would also use the chain of thought poisoning to actually bypass authentication. Then at the end, we have to capture the flag attack path. Once you've seen how it's done, we're going to leave the system running for a couple of hours because it's your turn to also play around the lab and get used to the lab. So we also have some tips and tricks to help you along the way. All right. This is our system architecture for what we built, right? So this setup is not just for the lab. It mirrors how a lot of companies are actually deploying LLM in production to automate their operations. So this is how our architecture look like. The first thing you're going to see here is the user interface. We can be a web app, a chat prompt, a command input, or a document a document interface. So basically, this is where you're going to be uploading your document, typing your prompt, whether you want to interact with the system or you want to manipulate the system. Everything starts from here. Then there's also the enhanced chat engine, which is labeled B. It has two components. There's the authentication module that verifies who you are and what role you have on the system. Then there's the message router that decides if your prompt is going to go to the LLM or to the tool, or both the LLM and the tool. Then in the section labeled the C and D is the LLM service layer plus the function router, right? So it's actually the module that is being processing the information that we got from our user interface, right? So it's going to help us actionate our prompts, whether we want to check, for example, the memory usage or check the CPU. Is going to help us route what we want to do to the proper model, whether the function calling model or the LLM service layer. Then we have the section labeled E, which is the vectorized database. So this is where the system actually pulls relevant context, logs, configuration file document from the vector database to augment your AI assistant. Then there is a tool integration layer. Once this action is being approved, any action you send via the user interface is going to go through the tool integration layer. So here you can run shell command, try to query the file system, or even run SQL queries. Then there is the role-based access control label G. Every true call is going to actually carry out a processing internally. It's going to ask itself, does this user have the permission to carry out this action before carrying out the action itself? Then the last component here is the back end system itself, right? So this is where the power lives, right? Our file system, our databases, our API, our CI/CD pipeline, and the cloud infrastructure actually lives in here. So the key takeaway from our architecture is we are not targeting the LLM itself because it's actually running on ChatGPT API. You're attacking the infrastructure that is being wrapped around it. So the real vulnerability is not actually in GPT-4 or in cloud, right? They are in the integration layer, the routing logic, the access control, and also the vector store, the way tools are being wired together in your system. That is the juicy part that attackers are willing to go after. And that's what we are going to be exploiting today. So next is our AI security methodology, because true red team don't just poke around randomly. They followed a very structured and repeatable approach. So here's a four-step framework you can actually use to access and exploit any LLM system, so that to make sure that your findings are actually meaningful, not just flashy. So the first thing you want to do is actually understand the system. You start with reconnaissance. This has to do with you mapping the surface area. What input and outputs does the system allow? What kind of API, tools, or function calls that can the LLM access, right? How is the agent wired into the rest of the system? So those are the kind of questions you're going to be asking yourself when interacting with the system. Then the goal here is to actually get clarity on what the system is actually built to do, so that your attack can be very precise and intentional, not just guesswork. Then the next one is the vulnerability assessment. This is where you're going to be finding cracks, where you're going to be looking for weaknesses, where you're going to be trying your prompt injection, whether direct or indirect. This is where you're going to try to leak data, try out weak role-based access control or broken authentication logic, or try to misuse the tool or call an unfiltered function. Basically, you're just hunting for any way to twist the system intended functionality just with natural language. Then there's also the exploitation. This is where you need to get creative, right? This is where the fun actually starts, right? Because you're going to be using your prompt engineering skills like a weapon. So your goal is to actually trick the assistant into running restricted command by passing permission checks, manipulating context, or retrieve data. So you're not writing code, right? You're writing clever instruction that is going to hijack the logic. Then for the last one, that's the impact analysis. So this section is where you're going to be translating the risk. So once you've confirmed an exploit, you need to step back and ask yourself, what is the real impact? Could someone steal sensitive data? Can this exploit be used to escalate privilege or move laterally within the system? What is the business fallout, right? Is this going to cause any breach or downtime? Can it trigger compliance violation or reputational damage on the company? And most importantly, can you explain it in a way that a non-technical stakeholder can actually understand the business risk of the vulnerability that you found? So you need to frame your findings in terms of asset as risk, financial exposure, and also business disruption. So this methodology is going to help you ensure that your testing is actually very rigorous, consistent, and directly translatable into real-world risk mitigation. Now let's get to the fun stuff. So I'm going to be uh, changing my screen here in just a second so that we can have access to the system. All right, so this is how our system look like. You can actually reach it on this IP, 178.128.162.162 on port 8501. So before we start hacking, let's go through some of the important components in the chart. So the first thing you're going to see here is the configuration section where you have the admin login. So you can log in with a username and a password. You also have a guest section in here if you don't have the admin credentials. Then you have the chat interface. This is the button that launches the chat interface where you can type in your natural language and send it to the LLM for processing. Then we have the document analysis section in here when you can paste in Markdown, HTML, log, configuration file, code, documentation, anything you want to analyze, and you can click analyze content, and the system is going to help you do that. Then there's a file upload section where you can upload document to the system, and it's going to help you analyze the document, whatever document you upload. Then you can also paste in a URL in here, and the system is going to help you analyze the content. And you can actually do a lot of things in here. You can run a vulnerability scan, you can check for hidden content extraction, try to do prompt injection detection and the likes of it. So then we have the knowledge base section. This is where user can actually upload document to the K8, that's to the knowledge base. You can also query the knowledge base to retrieve data from the system. Then you can download, but it's only admin that can that have the download functionality. Then you can also access the history. I've uploaded several malicious documents into the system already, which we're going to be seeing how to exploit later on. Then there's the attack simulator, which is an advanced feature for you. So if you want to try your hands on prompt injection just to see how it works in a simulator, you can use this section, but first you need to get the access key from the system. Then we have the tips and tricks checklist. Here we're going to be giving you different ways that you can actually exploit some of the vulnerability that is being packed in the system. Then at the end, we have an advanced capture the flag challenges for you, which you're going to be working on, which you are going to be working on personally, because we're going to leave the system for a couple of hours till the end of today so that you can try your hand to see if you can actually get the 2 flags from this system. All right, so let's get started. Okay, here we also have the Open API section where you can change the different models you want to interact with. There's the 3.5 Turbo, GPT 4.0 Mini. Then there's the temperature section. This section actually control the creativity of the system. You can lower the value, you can increase the value for more diverse and less predictive outputs. Then we have the security level in here because the system also has some sort of security in place, so you can change it from high to low. Then we have the live metrics in here, where the system is going to, it's just like a monitoring system that is going to be detecting the different actions that is being carried out by whoever is interacting with the system. Then please, you can go straight to the GitHub repo I shared earlier. We have 2 different attacks that we're going to be trying out today, which is the chain of thought exploitation and also the vector store poisoning. So we are going to start first with reconnaissance. First thing we want to do is just say hi to the system. How are you doing? So the processing is going to take just a couple of minutes. All right, so what we want to do now is to ask the system to probe the system for what it's actually meant to do. So what are your capabilities on the system? So it's going to take a minute, just a second. All right, so it's telling us that it can check system metrics like CPU, read logs, and also execute SQL queries, that means that it's actually interacting with some function. So to get an in-depth understanding of the function, we can ask the system what functions are available on the system and explain in detail how to use the available functions. So we're just going to wait for a few seconds for it to process. All right, so as we can see, so we can actually try to get the system metrics to check the CPU, memory usage, disk space use, and the likes of it. So let's try to see if we can actually run functions directly on the system. Okay, so we can run function on the system to check the CPU usage. So it's at 0.8% right now. What else can we do on the system? We can try to read log files. So let's copy this and paste this in here. So your outputs might actually be different from mine, but the concept still remains the same. So we are not permitted as guest users to actually to check the log files. Okay. So what else can we do? There is the execute SQL query. So let's try to see if we can execute SQL query on the system. Okay, so we can't do that as well. So there are also other functions like run shell command. This is super interesting. And also we can also list running processes, and they're only available to the admin. Nevertheless, let's probe this function properly to see how it's being used. So basically what we're doing is we're just probing the system to see what you can do, and the run shell command is actually very interesting. So let's see how we can actually exploit that. So it's actually used to execute basic shell command on the system. All right. So as a guest user, we don't have the permission to actually interact with this function. So if we try to do run command straight on the system, let's see what the output is going to be. As a guest user, we can't do that on the system. All right. But we already know that we can actually check the CPU, prompt for memory. For example, we can ask what is the CPU usage on the system. That triggers. We can also ask about the memory. Just say, tell me about the memory usage on the system. All right, so basically that's what we can do as a guest user on the system. So if we go straight to our workbook, I'm just going to open it on my end. You can also follow through as I do that. The first vulnerability in here is, please ignore the authentication bypass, because we're going to be using the chain of thought poisoning to actually bypass authentication. You're going to see how that will work in a couple of minutes. So let's talk a little bit about the chain of thought. So the chain of thought is actually it actually has to do with the reasoning step of the LLM system itself. So what we're going to be doing is we're going to be hiding malicious intent inside the logical reasoning of the system, so that the LLM is just going to think it's carrying out an action itself, rather than not knowing that it's actually carrying out a malicious action from the attacker, right? And why that is possible on the system is, let's go back to our slide, right? So what we want to first understand is, what was the developer intent, right? So the system is actually not built with a malicious intent. It was designed to help users troubleshoot issues intelligently. So the developer's vision was actually to create a DevOps assistant that could understand natural language, extract useful information, help users to walk through several problems. But where things went wrong is the fact that in the code, command are being extracted and executed immediately before checking if the user actually has permission to do that. But we actually run like an ls command, it didn't execute, but we're going to be using other different channels to actually do that, right? Then the second vulnerability in here is the overly permissive context detection, because the system tried to guess if the user was actually trying to troubleshoot using simple keywords like diagnose, debug, issue, problem, and the likes of it. So if any of these words appear in the prompt, the command will be allowed. Why? Because a developer wants flexibility, and there is no semantic understanding for the system, right? No real vetting of the prompt that is actually coming into the system, just superficial matching. So that is what we are going to be looking at. So if we go back to, let me add the system back to the stage so that we can see. So if we go back to our workbook, and let's go to the exploitation prompt section. So what we're going to do is we're going to copy the first exploitation that has to do with the basic chain of thought poisoning. So we're going to go back here, and I'm just going to paste in the prompt in here. So now this prompt is just us trying to probe the system, right? We are simulating what the system is going to do. The first thing is we are trying to say that I am going to troubleshoot this server issue. Let me check what files are running in what files are available on the system and at which current directory, and see what processes are running on the system to actually identify what the problem is. So by running this command, it's just going to take a couple of seconds to run. All right, so as we can see, the ls command was actually used to list the current files in the directory. So we have main.py, we have log.out, we have different application log. It's actually not listing everything in here. And we're also able to list the running processes using the psef command. So we were able to use natural language to actually exploit the system, because on a nonce we can't actually run this lsla command on the system, it will not go through. But by using this command based on the overly permissive context that the developer integrated into the system, we were able to run a different command. So let's copy the second command in here. This one is actually going to list out all the files in the directory, because we need some of them to carry out some exploitation. So it's just going to take a couple of seconds. Let me just copy the next one. All right, so what this just did is it runs the LSLA and it shows us all the files in our current directory. So we can see that we have a lot of files. We have this interesting admin token.txt. and it says the file could contain an administrative token used for authentication. We also have a format.txt. The purpose for this file is not known by the system. So, and we can also see that the system ran pwd, that's the present working directory command on the system to show us the present working directory of the system, which is this home DevOps agent. So what we want to do right now is let's run another command from our workbook. This one is the step-by-step reasoning, which is going to do, the first thing is going to do is going to examine the current directory structure, then is going to see what processes are active, then is also going to verify the user identity on the system. So it's just going to use the context in the system to run several commands. All right. So as we can see, it actually run LSLA, it lists all the files in the directory, and then it's just telling us about the different files in the directory, which are Python script and other data related to what appears to be a web application, which is what we're running right now. Then it tells us a little bit of information about the running process and also show us the present working directory. Now, because we've seen that we have this admin token.txt, what we want to do is let's copy this command and paste it again and try to pass in another command, and let's say, and then view the content of this file. Let's see if the system is going to give us the content of this file. All right, so we're able to get the content of the admin token.txt, which is the super secret token 123, and it's also telling us that the token might be sensitive and should be kept secure. Another thing we want to do is there's another txt file we want to check out. It's actually the format.txt. So we can just copy it and replace it with the admin token.txt. All right. So if you come across this issue about token, all you just need to do is just reload the system and paste in your prompt again. So this is just going to take a couple of seconds. All right, so we have the content of format.txt. Now we have admin and super secret token 123, which looks like a username and a password. So we're just going to type in the username in here, paste the password and try to log in. And as we can see, we are logged in into the system as an admin. Now, if you remember earlier on, when we're trying to run command directory on the system, we're not able to run it like ls. But now if we try to run ls on the system, it's going to take a couple of seconds. It's going to list out all the files in our our present working directory. So we can do who am I on the system. So it's going to tell us the current user is actually root. Now, so this is how you can actually use the chain of thought poisoning to actually exploit a system, right? By looking at the context of what the system is actually meant to do and taking advantage of that to run command on the system. Now, the mitigation for this is please, first, you need to try your hands on all the prompts. You can also come up with your own prompt based on the overly permissive context corpus on the system that we showed earlier. And the mitigation for this is you need to make sure that there is no more processing execution in the system, right? Command should never be auto-run, right? Just because a user says something that is reasonable does not mean that it's actually reasonable all processing should actually go through the LLM pipeline with strict validation and context validation. So that's one of the mitigation. Then you also need to carry out strict role-based access control on the system before executing anything. Check if the user is actually an admin. Check if the context is meant to call a command instead of just running it, and make sure that the command is calling is actually in an allowed list. There's no shortcut and no keyword faking in the system. Then input sanitization and validation is very important in any system. So keyword like system admin, because you're going to see an example of that in the chain of thought in our workbook, should not be allowed to trigger any command on the system. Then another mitigation is the architectural security of the system, right? You need to use separation of concerns in the sense that one component should handle authentication, another component should sanitize and validate every input that's coming from the different section on the system, and then another one can handle the LLM integration. Then before you give the output to the user, the final output should be checked again before execution. So, and the last one is actually auditing, monitoring, and pattern detection, right? You need to be able to track what the system is actually doing, right? So, repeated languages like admin, execute, by non-admin users should actually be logged, and suspicious natural language phrasing should actually be logged by the system and flagged immediately, and it should alert the administrator or the SOC Security Operations Center that you're using, so that they can respond on this and blacklist the user immediately on the system. So another vulnerability we are going to be looking at, which is the second vulnerability we're going to be talking about today, is the vector store poisoning. So the vector store poisoning is actually very powerful because unlike prompt injection, where the attacker is going to try to manipulate the model at runtime, so we're actually poisoning the data itself, right? So we are going to be uploading malicious data that have some command embedded into it. So by uploading this content, we're going to be inserting unauthorized command. We're going to be trying to use it to do different things on the system. And this is especially dangerous because it does not rely on fooling the model itself. It's actually poisoning the knowledge database on the system. And on this particular system, there is a critical vulnerability because the vector store itself is not being wired via the LLM integration system itself. It's going straight to the function calling, right? So any document you upload on the system and you're able to probe the document and try to run the command on the system, is actually going to run it without no filtering at all. So let's see an example on how to do that. So if we go straight to the knowledge base, so we have different actions that we can actually carry out on the system. You can upload documents, you can search and retrieve documents, you can download. It's only admin that can do this. We can also access history of a command that are on the system. So what you want to do on your end, if you go to the workbook, we have like a list of examples that you can upload on the system. So you can upload them as a PDF, as a TXT, whatever suits you. So copy the commands for each of the exploitation scenario, because we have the basic document poisoning, information extraction attack. We also have the advanced multi-vector attack on the system, right? But in our case, I have already uploaded several documents, right? So let me switch to guest, then try to access the history again. So basically what I'm going to do is I've already uploaded several malicious documents on the system. So I'm just going to query one of that to save time. So what I'm going to do is I'm going to say, what is the content of document tag this. So immediately it tries to fetches the document from the database, is going to run any command that is being embedded on the system, right? Which is going to, in our case, is just running a simple ls, and this is going to like show you the content of the present working directory. So where we have like a different file. So you can try your hands on it, try to do different things. And mind you, there are specific commands the system can act on. Not all command, they can't act on all command because we have some sort of safe list or allowed list of command on the system. So you can try your hands on that. So now, why was this vulnerability able to happen? So the intended for functionality was for users to be able to upload documents to the document store, query documents, search for documents on the system, right? But the mistake the developer made was actually first the LLM layer system is not the one processing the system. And the second vulnerability is a lot of vulnerability on the system. There is no proper access control done on the system because as a guest user, you're not supposed to be able to run a command on the system, right? So, but yeah, there's the weak access control on the system which allow the guest user to actually run command on the system. And these are the vulnerabilities in terms of the code. So there are other code related vulnerability in the system, and there are other vulnerability in the system like the path transversal vulnerability. Let's go to the attack simulator. I'm just going to enter the password in here. So I'm going to leave you to actually get the password yourself. All right, so we've spoken about the chain of thought poisoning. There's also the prompt injection. Here, there's also the path transversal that you can try your hands on. Basically, what this is doing is just reading log file, right? But it's just reading log file on the system, but there is a vulnerability in the system because the path is not properly concatenated. Is not properly input is not properly validated on the system. So you can pass in $/etc pass WD on the system, and if you try to read the log file, it's going to give you the content of etc pass WD. Same thing for the symlink attack and the path normalization bypass. Then the vector stop poisoning is similar to the one we discussed earlier. You can add in your content in here and the system is going to run it. For example, there is an example of a poison document that we can add in here. So all we just need to do is just paste it and add the document. Then if we go to the document store and let's query for doc. So we saw a little bit of similarities, and it's automatically going to run the content, the malicious content in the document we uploaded earlier on, and it's going to show us the content of etc/wd. So there are a lot of attacks you can actually try your hands on the system, and we're just going to leave that to you so that you can try this different attack yourself, see how they work, come up with creative ideas to actually exploit the system. Then the last thing I'm going to show you here is the tips and checklists. We have two different attack pack on the system. Now you have seen how you can actually elevate your privilege from a normal guest user to an admin user. So what you can do here is find a way to get these two flags. There is actually another application running, an API server running on the same IP address but on port 9000. I just pasted it in the chat. Oh, sorry, I thought I was actually showing the tips and tricks. So there's an API server running at port 9000 what you need to do is find a way to actually extract the flag from the API server. Then there is a connected network, in the connected VPC that's connected to this server, to this DevOps assistant server. So you need to look for a way to actually exploit the connected VPC. So if you're able to do that, you can send your flags to this email address. So we're going to leave the server running for the rest of the day. So I'm definitely sure before the end of the day, somebody is going to be able to get the two flags. So you can send it to us so that we can stop the server from running. All right. So let's go back to our slide. Now, the key takeaway from there's a question. So you actually need to look for a way to find the password. So the password is actually similar to the admin password. So you need to just put on your hacker hat and just find a way to look for the password to the demo environment. That's if you're asking for the attack simulator. But for the demo environment, this is the IP address. So all you just need to do is just paste it on your browser and you're going to have access to it. It's actually running and it's going to be available throughout the rest of today, even tomorrow. Now, the key takeaway for us is when you give AI the ability to act on natural language, the line between code and data is going to disappear, right? So that protective wall between harmless input and dangerous execution is going to melt away. And this is why attackers thrive in AI configured or integrated system. And we need to understand that LLM security is not just a design issue, right? It's not an architectural problem. It's not just the model that has the issue, right? Attackers are not really raving to crack ChatGPT 4 or Claude, right? They are targeting the ecosystem around it, what you're building around it, the API, the vector databases, the tool integrations into the system. And the tool defense begins with threat modeling. So you need to carry out threat modeling on your system. If you're actually integrating this AI into your system, you need to trace every integration point and ask what happens if this is actually manipulated. Then integration points are your greatest risk, as we said. So if you have some integration like the function calls, vector databases, like some MCP, you need to make sure that you're properly authenticating, you're carrying out proper rate limiting, and you're logging every interaction from every users. Then the next point here is natural language can behave like code. Yes, right. Natural language is not equal to harmless input anymore. So you need to treat every prompt like a line of code. So you need to use strict schemas, input contracts, and also predefined command set on the system if you have to use command at all. And also make sure that you're not trusting the user to actually stay within the line, because users are going to look for several creative ways to manipulate a system. Then another thing you want to do is you need to carry out defense in depth, right? Input check at every stage, for example, from the UI stage, the chat layer, the function handler, or the orchestration in the system. You need to carry out input validation and sanitization on the system. Then another thing you can do is isolation. Make sure that your AI is running in low privilege containers instead of running them in network that are connected to your subnet, right? So that is going to make sure that lateral movement is not possible on the system, and there is no way for an attacker to actually carry out a full compromise. Then monitoring and alerting is actually very important. You need to be able to track what your AI system is doing, how it's doing. For example, if your AI system suddenly open 20 SSH sessions, right? It's not being F4 anymore. It's actually probably being hijacked by an attacker. Then we need to understand that security is not a one and done task, right? Threats evolved weekly. Remember, we spoke about the 2025 SVG XSS injection. Is not going to be the last one, right? You need to budget for ongoing security audits Get help from experienced auditor like Hacken, because auditing is not just an afterthought. You should not take it as an afterthought. You actually need to start testing your system right from the development stage, right? And you also need to make sure that you're carrying out proper remediation and ask questions after this test. So for the next slide, so yes, what we can do next is, if we put security first today, from planning to monitoring, we'll be ready for whatever AI throw at us tomorrow. Which means that the first thing you want to do is, if you're already integrating AI into your system, you want to run a full AI security audit, right? Whether you are integrating with OpenAI, Anthropic, or other provider, build your own guardrails outside their model, right? You can also carry out simulation like red team, blue team exercise that's focused on prompt injection, tool hijacking, abuse, or memory manipulation, depending on what your system that you've built around this model is actually doing. You can also simulate attack from the OWASP LLM threat suit. Then white box testing is actually very important. Let security expert actually look at those code, audit them for security vulnerabilities, and also hit your agent with adversary input at every build stage. Then you need to review your role-based access control. You need to review every endpoint, every function call. Make sure that you're checking for missing security context, right? Then apply least privilege at every prompt. If your AI or your AI integration does not need a tool access, don't just give it the access. Then implement input validation and sanitization. I know this is the second time I'm saying this. You need to treat all user input as hostile. Rely on whitelist, never rely on any vague pattern matching on the system. Then deploy monitoring and alerting. You need to log every step that the AI is actually carrying out, from the prompt injection to the function call to the execution to the response, the whole life cycle of the AI system. You need to log them, and you need to build dashboard that is going to help you track the usage pattern and flag any anomaly on the system. You can also use, I'm not sure if there are any SIEM that can actually understand LLM behavior. You can build one for your own system that actually understand this prompt, not just some infrastructure logs. Then you need to stay updated to keep your threat intel fresh. You can follow up update from OpenAI, Anthropic, different cloud providers. There's also Microsoft. Then you can also follow our blog post at Hacken for security advisory and security blog posts on how to lock down your system and how to exploit these vulnerabilities in the AI system. Then you can subscribe to different AI security newsletter and stay plugged in. Now, to the call for action, AI is actually reshaping our world because, it's very effective and very efficient, and it actually works. But if we don't build defensively, we are not innovating, we are actually gambling with security. And zero trust is not about paranoia, it's actually being realistic, because assuming that nothing is safe by default is actually very important, because history has shown that nothing is actually safe by default. Because if everything is safe by out of the box, for example, there would be no hack, no CVEs. And another thing we need to remember as a community is the vulnerability we spoke about today and exploit today, and not just hypothetical, is actually happening, right? We've seen several use cases or an incident that has been caused by prompt injection. Then another thing we have to do as a development community, or an AI security community, is we need to make sure that we are building smart from day one. Don't wait till after deployment before you are implementing security into your stack. Apply proper validation and sanitization for both your input and output. Then you also need to plan for compliance, because government are cycling regulations like okay. I'm actually sharing my screen. All right, so regulation like GDPR, EU AI Act, and IPA, they require you to be really transparent. Your system needs to be explainable and traceable, right? And there are some regulation on AI that are going to come up very soon. So we need to be ready for that. Then the last call for action today is we need to add a checkpoint to autonomous agent, right? You need to have human in the loop, especially if you are connecting AI to critical action, for example, deployment, file execution, or transaction. AI is very fast, and approvals and checkpointing are your brick. So make sure that you're using them properly to avoid a crash. All right. Thank you very much for spending your time with us today. I mean, you've seen how powerful these systems are and how easy they can be subverted without the right defenses. And we also talk about the framework that you can actually use to test the system, from the reconnaissance to the exploitation to the impact analysis. And we've shown a couple of live examples. So you are now in a strong position to understand what you actually need to secure your AI deployment without slowing down innovation. So thank you very much. And now let's open the floor for questions from your side. Does anybody has any question for me? Thank you very much. So we'll just wait for a couple of minutes in case anybody else has any question before we call it a day. All right. So to request for an AI security audit, you can scan the QR code on the slide, and we're going to jump on a call with you, try to understand what you've built and how we can come in terms of security. To accessing the environment, I am going to share the IP address with you. So we're going to leave this running for a couple of days. So in the next coming month, we're actually going to make the environment open source. So, and we're going to put up an announcement for that. And immediately we're able to do that, you can actually. Oh no, the system does not detect for bias in LLM models, right? Because the system is actually connected to OpenAI API. So what we're doing today is actually targeting the integration point, not the bias in the model itself. So I'm just going to scroll up to see if anybody asks any question. Okay, thank you very much for joining us today. In case you have any other questions, you can send them to my email that I shared earlier on. I'm also going to just type it in here. So in case you have any question, just send it to us and we'll make sure to give you an answer. Thank you very much and have a great day.